Greetings, everyone, and welcome back to our continuation on substrate pH and all the factors that can affect it. Today, we'll be talking about fertilizer type and the rate and that impact on substrate pH. So we can kind of break down water-soluble fertilizers into three very broad categories: acidic, neutral, or basic. Now, an acidic fertilizer, such as this triple 20, is going to be higher in ammoniacal nitrogen compared to a basic fertilizer like a 13-13, which is going to be lower in that ammoniacal nitrogen. So your ammoniacal nitrogens often do not supply calcium magnesium as well. And we can kind of rate these based upon their potential acidity or potential basicity, which is commonly put on the guaranteed analysis bag. Like this triple 20 has a potential acidity of 555 pounds, compared to this 15-5-15, which is considered basic at a 77-pound basicity. So taking into account that in terms of the milliequivalents that you can neutralize for your alkalinity or add in buffering capacity. There's a wide variety of fertilizer types out there on the market, and understanding that potential acidity slash basicity, and then your theoretical milliequivalents of alkalinity that you can neutralize with it. So shown here at that triple 20, at 100 part per million, you can neutralize 2.4 milliequivalents of alkalinity, and then increasing that up to 250 part per million nitrogen can do almost 6 milliequivalents of alkalinity neutralized. However, looking at pairing that rate for the crop that you need, or the crop that you're growing, along with that fertilizer type that's going to complement the crop's needs. And then looking at basic fertilizers such as a 13-13. Here in North Carolina, we're not over limestone, so we don't have that extra calcium magnesium in our water supply. So having a CalMag fertilizer is very important to supply the crops with what they need to grow. So what's exactly happening in our root zone? When we apply a fertilizer, that root really wants to stay at equilibrium. So when you apply ammoniacal nitrogen, an acidic reaction is occurring, and that plant is kicking out a hydrogen ion. Additionally, with a basic reaction, such as adding nitrate nitrogen, it's going to kick off an hydroxyl ion, an OH, which would then drive up the pH. So that root is going to constantly want to stay at equilibrium, which is great. Now, matching your fertilizer rate to equal the plant's uptake. This is from Dr. K. Young Jung's PhD work with Paul Nelson. Looking at Kalanchoe at 100 part per million, this is what we would expect to see of acidic fertilizer dropping that pH much more considerably than a basic or neutral fertilizer shown here. Now, we see the basic drops just slightly over time, about 0.1 pH units, which is very minor. In that acidic dropping roughly 2 entire units. Now, that was at 100 part per million. Now, when we exceed the plant's uptake with 200 part per million nitrogen applied, notice that all three drop the substrate pH drastically. And so kind of what's occurring is that there's so much extra salt applied into this environment that we have all these extra hydrogen ions occurring. So you are not out competing the reaction that's occurring. You're just adding a lot of extra hydrogens, which are driving down your pH. So matching your fertility rate to the plant's needs are critical in order to really prevent that pH drop, even when using a basic or neutral fertilizer. So kind of what's our take-home message and takeaways moving in? Fertilizer type selected can be used to add buffering capacity in low alkaline water conditions, or neutralize alkalinity in high alkalinity conditions. Matching your fertilizer rate to your crop's need is essential to prevent that pH decrease, regardless of your fertilizer type. Using various fertilizer types and manipulating that rate can help you control growth and manage your substrate pH as well. And with that, thank you everyone for tuning in.